Hi friends, Ethan here. I just want to take a few minutes and discuss the upcoming solar eclipse. So this is the North American total solar eclipse that'll be happening next month. So just over 10 days from now, actually. It'll be happening on Monday, April 8th, during the daylight hours. And I want to answer just 3 questions that I've gotten about the solar eclipse. So the first question is, number 1, what is a solar eclipse? Number 2, why is this eclipse special? Number 3, what will it look like? Number 4, how can I view the eclipse? And number 5, will there be clouds? So, with that said, let's get into it. Question number 1, what is an eclipse? Well, in its simplest form, an eclipse is when the shadow of one object passes over the surface of another object. When we're talking about stuff up in the sky, we're talking about 3 different objects. Number 1 is our sun. The sun is the light source for all of the shadows. The other 2 objects are the moon and the earth. So the sun causes both the moon and the earth to cast shadows. When the earth moves between the sun and the moon, and when its shadow passes over the surface of the moon, we call that a lunar eclipse because the shadow is on the moon. When it's the other way around and the moon is between the sun and the earth, and the moon's shadow passes over the surface of the earth, we call that a solar eclipse. So a solar eclipse is literally just the shadow of the moon moving across the surface of the earth. Now, you may be wondering, the moon goes around the earth every 28 days. So why isn't there a solar eclipse and a lunar eclipse every 28 days? That's a really good question, and it turns out that the answer is because of the moon's orbit around the earth. Now, the moon doesn't move in a perfectly flat circular orbit like we might think. Instead, sometimes it passes high in its orbit, other times it passes low in its orbit. And what happens is it kind of wobbles back and forth. It's because of this wobbling that we don't get a solar eclipse every 28 days. Instead, sometimes the moon is too high, sometimes it's too low, but it has to be just perfect in the middle between the sun and the earth in order for that eclipse to occur. All right, question number 2. Why is this eclipse special? This eclipse is special for a couple of reasons. The first reason is that eclipses are pretty rare. We here in the United States are fortunate in that a couple years ago in 2017, we had a total eclipse. And now just a few years later in 2024, we're having another solar eclipse. So back-to-back solar eclipses. But if we expand out a little bit, prior to these 2 solar eclipses, the last solar eclipse, total solar eclipse to pass through the United States was all the way back in 1979, so over 40 years ago. On the flip side, if we look to the future, the next total solar eclipse in the United States won't be until 2044 or 2045. So over 20 years in the future will be the next solar eclipse. So this is the last one for a while. The other reason why this solar eclipse is pretty special is because it's going to last a relatively long time. Solar eclipses can last anywhere from 0 minutes all the way up to about 7 minutes. The one that we saw back in 2017, that one only lasted at its peak about 1 to 2 minutes long. But this one in 2024 will last 3 to 4 minutes, so it's a little bit more than halfway to that 7-minute benchmark, that 7-minute maximum for a solar eclipse. So it's a relatively long eclipse. The third reason why this eclipse is special is because nearly everyone in the United States will have the potential to see this eclipse. Everyone from Maine to Hawaii, to Florida, to Washington, even up into southern Alaska, they will be able to see part of the eclipse also, potentially, if there's no clouds. As well as the rest of North America, from Canada, Mexico, and all of Central America. Now the big question, What will this eclipse look like? Number 3. So to answer that, I made this map here. Now, this map depicts what kind of changes we can expect in the sky, assuming that there's no clouds, that we don't have cloudy skies. So this assumes that if it's a blue clear sky, what's going to change? First off, we have this green zone from Maine through northern New York down into Texas. This is the path of totality, where the sun will be 100% blocked by the moon. In this area, we will have complete change in sky conditions. The eclipse will be readily visible with the naked eye, and all of the blue color in the sky will be lost. Even if it's cloudy in these areas, there still should be somewhat of a noticeable difference or darkening of the sky. You can almost think of like when it's cloudy at night, we still know that it's dark. In these yellow areas, so from Maine through southern New York into Texas and up into Michigan, this area is where we will be able to see a detectable change in the color of the sky. Now, what I mean by detectable changes is that the eclipse itself will not be visible with the naked eye. You won't be able to see the sun get blocked by the moon, but the color of the sky might change a little bit. How much it changes will depend on where you are. If you're closer to the red area but in the yellow zone, there'll be slight changes. But if you're closer to the green area but in the yellow zone, there will be more changes in the color of the sky. Now these changes might vary from just a dulling of the sky color to maybe a hazy color, all the way up to a darkening kind of tinting of the sky, getting a little bit darker. Now, these areas in the red, everywhere else, so the western United States, Rocky Mountains, Arizona up to Minnesota, as well as the southeastern United States from North Carolina down through Columbia, South Carolina into Georgia and Florida. These areas are what I consider to be the no detectable change areas. So what that means is, if you were to look at the sky with your naked eye, just go outside during the peak of the eclipse, look at the sky with your naked eye, you wouldn't be able to see any change. You wouldn't even know that an eclipse was happening. No color changes, not visible. Now, one way to think about these color changes that I pointed out here in this map is actually kind of very similar to the tinting on a car window. They work the same way. So the tinting on a car window works by blocking a percentage of the sun, and the same thing happens with the moon during an eclipse, and it blocks a percentage of the sun. Below about 80%, that's where it's difficult to tell that anything has really changed. And so it doesn't look like anything has changed with the colors on the other side of the window. That corresponds to our red areas on the map. So that's the areas that are below 80% of the sun being blocked. Once we get above 80%, from 80 to like 95, 97, 98, 99%, those are these upper areas where basically enough of the sun is being blocked that we start to notice some color changes, whether it's in our tinting or in the sky color. Those correspond to our yellow areas here, where we'll be able to see some change, but not all the way. And then the last, of course, is if we were to block out 100% of the sun, it's going to be black. You're not going to be able to see through that window. That is what's going to happen along that path of totality in that green zone. To give you another idea of what this might look like, back in October of 2023, we had a solar eclipse here in Arizona. This is what it looked like at 50 to 60% right after the eclipse. And I couldn't even tell the difference between the sky at zero at that point. It looked just as if there was no solar eclipse. The sky was blue, the sun was shining, even though 50 to 60% of the sun was blocked, which just tells you how strong the sun really is. You can block out half of it and you don't notice a difference. Once it got up to about 80 to 85% of the sun being blocked, that's when I started to notice those color changes in the sky color. So that's when it started to get a little bit duller, a little bit hazier. And that's what we see in this second picture over here. So you can kind of see that difference in color. All right, and that brings us to question number 4. How can I see the solar eclipse? Now, I already said that not everyone is going to be able to see the solar eclipse with their naked eyes, or will be able to notice it. So if you're in Arizona, Colorado, or even Florida and South Carolina, You won't be able to see the eclipse with your naked eye, but you can still see the eclipse as long as there's no clouds. What you're going to need to see the solar eclipse, though, is called a solar filter. And there's two types of solar filters that we can use. The first one, and the most common one, is going to be solar glasses, a pair of solar glasses. Solar glasses work by basically filtering the sun's rays, both the harmful ones to us as well as the light coming in, that extra light, so that we can see what's going on the sun. So I mentioned that back in October of 2023, we had a solar eclipse here in Arizona. This picture that you see on your screen right now, this is what the solar eclipse looked like without solar glasses. So if I was to look at the sky, this is what I saw. I saw the sky, kind of bluish, and I saw this big, bright blob of sunlight in the middle. Couldn't see what was going on with the sun, I just knew the sun was there. But when you put on the solar glasses, this is how it looks instead. The solar glasses filter out all that sunlight so you can actually see the disk of the sun and the circular disk of the moon. So here, this orange, that is the sun. When there's nothing in front of it, it's a complete circle because the sun's a circle. But in this picture, looking through the solar glasses and taking a picture, we have the circular disk of the moon in front of it. And that moon is blocking out part of the sun so that we can see what is going on during the eclipse. That's how you can see the eclipse in places like the western United States or the southeastern United States, where it just won't be big enough to see the color changes in the sky. Now, if you still have some time to order solar glasses, if you don't already have some, so if you want to order solar glasses, one place you can go to is B&H Photo. So if you go to Google, type in B&H Photo, and you can go onto their website. And on their website, you can search for Solar Eclipse glasses. Solar Eclipse glasses. And you can purchase them from there. They have solar eclipse glasses. Another place that you might be able to get solar eclipse glasses is at your local museum or library or science center or even some schools. Different communities throughout the United States are having viewing parties where they may be handing out solar glasses. So do some research, see if there's anything going on in your town or region. Now there is another way to see a solar eclipse on a sunny day if you don't have solar eclipse glasses, and that is to make our second type of solar filter. This is called a pinhole filter. Now for a pinhole filter, literally what you do is you just poke a pin-sized hole in a piece of paper and then look at the shadow. So on my hiking trip back in October when I saw that eclipse, I had a manila envelope in my folder. You can see the natural hole from the envelope at the top where the brass bracket would go. And over here by my finger, I poked a small hole with the tip of a pencil. When I held that up in the sunlight and the sun was shining through it, I was able to see the shadow of the moon moving across the sun. And that's what this is right here. So here we have the crescent here. That's the sunlight. In this inner part, this inner circle, inner curve, that's the moon blocking the circular part of the sun. So just like we saw in our solar eclipse glasses, with the sun being this orange part blocked by the moon's disk, you can do the same thing with a solar eclipse, or with a solar filter, with the pinpoint solar filter, where it blocks part of the sun's disk and you can see how it's progressing. So there's two ways to view a solar eclipse. I do want to say that neither will work if it is cloudy. The cloud just blocks it too much. You're not going to have that shadow. The solar glasses aren't going to be able to see through the clouds. So it really depends on there being no clouds. The last thing that you need to see your solar eclipse, so how do you view the solar eclipse? Second thing that you need is you need to know when to look. Solar eclipses happen fast. They only last for about 1 to 2 hours. So I'm going to show you a website where you can look up the time of the eclipse where you are. So the one that I like to use is called timeanddate.com. So if you type in timeanddate.com like that into Google, it's going to be the first result, timeanddate.com. So once you get onto this site, they do have a solar eclipse section down here at the bottom. You can click that. On this page, it'll give you some general information about the solar eclipse. But if you go up to here to the search box, you can search for your specific location. I recommend that you type in your zip code, so I'm going to type in 850204 Phoenix. And then I'm going to click on Phoenix, and it'll take us to this eclipse page for Phoenix. I'm going to click on the April 8th, 2024 solar eclipse. And on that page that it then takes us to, it'll have all of the information about the solar eclipse for April 8th. Here, I'll be able to view things like the time that it begins, so it begins at 10:08 a.m. here in Phoenix, the time that it peaks, or the maximum, which is at 11:20, and the time that it ends at 12:35. So it's only going to last about 2.5 hours here in Phoenix. It'll also tell you how much of the sun is blocked. That's what this magnitude is. So that 0.704 means that 70% of the sun is going to be blocked here in Phoenix. I also like this page because if you scroll down and click on this animation, it'll give you kind of an animation of the eclipse to give you an idea of what the sky will look like at different times. So here we can see the moon starting to move in front of the sun, and then here's the maximum. Sky's still blue. Notice how I said the sky's still blue. Can't really notice a change in Phoenix. And then it starts to depart. So that's the website that I recommend. Very user-friendly. I recommend that you use the zip code for that search bar. And then that takes us to our final question. Will there be clouds on April 8th? Unfortunately, it is still too early to know if there will be clouds on April 8th. We're still over 10 days away. We really don't start to get a solid idea of whether or not there will be clouds until we get down to about, at the most, 7 days, but more realistically down to like 3 or 4 days, just because it's so hard to pinpoint a particular hour if there's going to be clouds. This far out, forecasts are just going to be flip-flopping. They're not reliable if you've seen them. It's not till we get less than 7 days, really down to that 3 to 4 day range, when we get a good idea about the cloud situation for the eclipse. That being said, we can take a glance at climatology to get a rough idea of the cloud situation around April 8th. So this map here, this is a map that I made from a couple of weather databases looking at sky cover during eclipse time on April 8th. So what we see here is map of the United States, and this red path is our path of totality. Now, areas in gray, so the Pacific Northwest, Minnesota, northern New York into northern New England, these gray areas are unfortunately the parts of the country that have a high odd of seeing clouds on eclipse day. In these gray areas, there's historically been 75% chance of cloud cover. So if we look at the past 50 years, 75% of those years had clouds at the eclipse time. If we look at the rest of the country, this ugly mustard brown color, that is the part of the country where over the past 50 years, 50 to 75% of those years have had clouds at the eclipse time. It isn't until we get down into like the southeastern United States, from Arizona, New Mexico, Texas, down into Florida, that we start to see areas with less than 50% chance of seeing clouds historically out of the eclipse time. Unfortunately, early April really just is a cloudy time of year in the United States. But that being said, we'll try our luck and we will see what happens. Hopefully you get a chance to see the eclipse. Hopefully those clouds stay away, but we'll just have to wait and see. If you don't get to see the eclipse because of clouds, I still recommend that you get yourself a pair of solar eclipse glasses, because you can use them any time of the year, on any day, to look at the sun and to actually see the disk of the sun in a way that you really can't see at all without them. So that's what I've got on the eclipse. I hope that gives you some information. If you have questions, feel free to message me in the comments or on Facebook or directly, or however you want to let me know. But yeah, happy viewing, good luck, be awesome.